Let me go ahead. We are now recording. And let me go ahead and find the section that we're starting with. Okay. That's not it. There we go. Okay. So let me go ahead and can you still see the Microsoft OneNote that says section 1.6, solving other types of equations?
Yes.
Okay, cool. So today what we're going to do, solving other types of equations, this section is the big one that I was telling you about last week, that has 4 new types of equations that we're going to learn how to solve. And so I always sort of approach this section differently because I'm trying to find the best way to approach these types of equations. But what we're going to do today is start off with solving what are called quartic equations. Sorry about my handwriting, guys. It's hard to write on the screen, so just bear with me. Quartic equations that are quadratic in form. Okay, and what I mean by that is that you're going to have equations that look like this: ax to the 4th power plus bx to the 2nd power plus c equals 0, something like that. Now, this is the quartic equation because it's a degree 4 polynomial. It has that exponent of 4, and just to compare and contrast, remember this sort of looks like our standard form for quadratic equations, which would be ax squared plus bx plus c equals 0, right? That's standard form for our quadratic. Okay. Now, even though this is a new type of an equation, we have all of the skill sets that we need to solve a quartic equation if it's quadratic in form, because all we need to do to solve this is use the AC method to factor the quartic polynomial, that trinomial, the ax to the 4th power plus bx squared plus c, that's going to be factorable. Okay. I'm fairly certain that in this section and in the homework, you will not see one of these problems that is not factorable. Okay. Now, I mentioned that this is a 4th degree equation, and what that means is that you will have at most 4 solutions. Okay. Okay. So in the same way that a quadratic equation has 2 solutions, and the 2 is sort of indicated by this exponent, right? The degree tells you how many solutions that there could be. The quartic equation is going to have 4 solutions. Okay. Does anybody need to write that down still?
I'm good.
Okay. I'm going to go ahead and scroll down. Again, I sort of think this is one of the things that we learn best by just doing and jumping into a couple of examples. So we're going to start off by solving the equation x to the 4th power minus 5x squared minus 36 equals 0. Okay. And as I usually do, I usually make a little line over here and I put my scratch work to the side. So I always like to set up scratch space so that I can get some extra work done, since we are going to have to do some factoring and some other things. Okay. So if I wanted to start factoring this trinomial that I have, let's forget about the equals 0 part, right? We're just looking at ax to the fourth x to the fourth minus 5x squared minus 30. How would I start off the AC method here?
You would multiply x times negative 36. So 1 times negative 36.
That's correct. I want to correct you a little bit here. You're not multiplying x times the 36. We're just saying that there's an understood 1 in front of the x to the fourth power, right? The coefficient here is 1, so that's where we get the a value from, a times c, which in this case is going to be the 1 times the negative 36, right? That's going to be 36. I'm going to reset, negative 36. And then we can look at all the factors of negative 36 and go from there. So the factors of negative 36, just ignoring the negative sign for a second, 1 and 36, 2 and something, right? 2 and 18, 3 and something else, 3 and 12, 4 and 9, and then we get to 6 and 6. Now, of those factor pairs, if we're trying to apply the AC method, we need to choose the factor pairs that multiply to make that negative 36, but also add to make the negative 5. So which of these numbers look like they're going to combine to get us close to a 5 or a negative 5?
4 and 9.
Yeah, 4 and 9. So we can choose 4 and 9. Now, one of those has to be a negative, since this negative 36 is the number that we're dealing with, right? And we're only going to get those to multiply to be a negative if one of those numbers is a negative. So we have to make the 9 the negative because it's the larger of the two. And if we had 4 plus negative 9, we would get that negative 5 that we want here in the middle. Does that make sense?
Yes.
Okay. So once we know that, we can go ahead and break up the middle term like we've done before with the AC method. And we could put the 4, now we have to put x squared there, because they always take the variable of that middle term, okay? So you have to watch out in the solving a quadratic equation, that middle term was just an x. So we would put 4x minus 9x. But when we're solving a quartic equation, that middle term is an x squared. So we have to put 4x squared and then minus 9x squared. That's a positive 4x squared. Okay, does that make sense?
Yes.
Okay. They both need to take on the variable of that middle term, because if we were to combine the 4x squared and the negative 9x squared, they combine to make the negative 5x squared. So we haven't really changed the problem. Fundamentally, we've just changed what it looks like. But now that we've done that, we can bring the first term down, the x to the fourth power, and the last term down, negative 36. And now we have a 4-term polynomial that we can then factor by grouping. Okay. Does anybody have any questions so far?
No.
Okay. So then looking at the first 2 terms, what is their greatest common factor? What do they have in common?
X.
They do have an x in common. Is it just one x that they have in common? What is the most x's that you can take from each term?
2.
X squared.
Yeah, 2 or x squared, right?
2.
So we'll put x squared, open up our parentheses, and then if I factor out x squared, if I factor out that GCF, what should I have left over in the parentheses?
X squared
X squared, good,
plus 4.
plus 4, perfect. That's exactly what we need to see. If we were to multiply that forward, x squared times x squared gives you x to the 4th power. X squared times 4 gives you the 4x squared. So we're good to go there. Now, looking at the next two terms, what do these two terms have in common? Keeping in mind that because the first term is negative, we're going to factor out the negative DTM. Okay. But what do 9 and 36 have in common?
The 9 can go into 36.
Yeah. So 9 is going to be the largest number that goes into both 9 and 36. So we're going to factor out that negative 9. And then here is where I said in the past, if you don't want to think too hard about what's going to go next, and I know that when you factor out a negative, it's sort of hard to think about, then just go ahead and transplant this x squared plus 4, since we know on the next step, those need to match, okay? Now, once you've done that, you do have to do some thinking to make sure that that works, that multiplication works out. And it, sure enough, 9 times x squared gives you the negative 9x squared. Negative 9 times 4 gives you the negative 36. So that does match. That does work out. And does that make sense?
Yes.
Okay. Cool. Well, now that these guys inside the parentheses match, well, that's the greatest common factor of these next two set of terms, so that we can factor that out just like we've been doing with the ACM method before, even though it's an x squared plus 4. And then this one is an x squared minus 9. We can factor that out, okay? So that completes our factorization. At least, you might look at this x squared minus 9 and say that that can be factored further. But for our purposes, to make it look like what we've seen before, those are the two factors that we have, x squared plus 4 and x squared minus 9. Does anybody have any questions there?
No.
Okay. Does it feel pretty familiar so far?
Yes.
Cool.
Yeah, it does.
Okay. Well, when we solved quadratic equations, at this point, we would have two what we would call linear factors. That is, you'd have x plus some number and x plus or minus some other number, right? In this case, the factors have x squared in them. So what we'll do here is very similar to solving quadratics. We're going to use the zero factor property. Because the situation that we have is that this thing times this thing equals 0, right? When we bring that 0 back into the mix and we solve that equation. We have a polynomial times another polynomial that equals 0. The only way that's going to be true by the zero factor property is if either x squared plus 4 comes out to equal 0, or x squared minus 9 is equal to 0. Okay, so just like when we get to the end of solving a quadratic equation using the zero factor property, we're going to be able to use that here as well, because we have a factor times a factor and we get 0. So one, the other, or both of them must be equal to 0. Okay, but the trick here is now that these little equations that we've set up and set equal to 0, they're not linear equations. They're quadratic equations because we have x squared. That means that from each of these little equations, when we solve them, we will get two solutions. So I'll get two solutions from solving this equation, and I'll get two more solutions from solving this equation. And that's where we're going to get our 4 solutions from. Okay. So looking at this one on the left-hand side, the x squared plus 4 equals 0. How would you want to go about solving that equation? What feels like a good first step?
Subtract 4 from each side.
Yeah. So that's a good first step here because we don't have a whole lot of terms. We just have 2 terms. So if we could isolate the x squared and subtract the 4 from both sides, that's going to be really useful here. So we'll get x squared, these cancel out, is equal to -4. Okay. Now, when we solve this thing, we want to get x by itself. So how do we cancel out the square operation of that exponent of 2?
You want to use square root?
Yeah, we're going to use the square root property here. Right, so I'll take the square root of both sides. I'll have x is equal to, don't forget your plus or minus. Remember, you need to have 2 solutions from this equation. And then what is the square root of -4?
2. Positive 2.
Be very careful there. Okay,
But-
so
Don't you have to have an I?
yes. So when you take the square root of a negative number, just remember you're going to get an imaginary number here. So if we take the square root of -4, that's going to give us 2i. Okay, so those are our 2 solutions from that equation: positive 2i and negative 2i. It's okay to get imaginary solutions for 2 of those, right? So long as we've done everything correctly up to that point, we should be good. Okay. Does anybody have any questions?
No.
Okay. Now we can turn our attention to the last quadratic equation that we have over here. And how do you guys want to start this one off? The x squared minus 9 equals 0.
By adding 9 to both sides.
Yeah, that's exactly right. We're going to solve it very much the same way that we solved the last one. So we're going to look at that -9 and add 9 to both sides, so we can get the x squared by itself. X squared is equal to 9. Okay. Then we can apply the square root property by taking the square root of both sides. The square and the square root will cancel out. So we have, we just have x now is equal to plus or minus. Don't forget your plus or minus. And what's the square root of 9?
3.
Just 3, not 3i. It's a positive number. You can throw the square root of 9 in the calculator and you will get the number 3. Okay. So those are our other 2 solutions. So again, if in MyLab Math, when you're typing in your answers, they give you the plus or minus button, you can just put plus or minus 2i, comma, plus or minus 3, and that would be your solution set. But if for whatever reason you needed to see it all written out in expanded form, then your 4 solutions are 2i, comma, -2i, comma, 3, and -3. And it doesn't matter what order you put these in. Okay, these 2 things mean the same, but we have 4 solutions since we were dealing with a Quartic equation. Does anybody have any questions there?
Oh,
No.
Did that feel pretty straightforward? That felt like solving a quadratic equation?
wait,
Yes.
I have a question. Are
Yeah.
we supposed to write it like the first solution set or the one below it?
So what I was saying is that in MyLab Math, they'll accept it as the first version,
Okay.
the condensed version, that's fine. But you need to be able to look at both of those and say like, oh, those are the same solution set.
Okay.
This one is just
Okay.
condensed.
Right. Okay.
This one is just expanded out. Yeah.
Got it. Thank you.
Any other questions?
No.
Okay,
No.
sounds good. Was anybody still writing this down? Okay. Let's go ahead and jump into another example. So I want you guys to solve the following equation. 4x to the 4th power plus 3x squared minus 1 is equal to 0. Okay. So let's do this. Walk me through this. What do I need to do to start? And you can go ahead and look at the last problem that we just worked and try to figure out what the steps should be. Right? Tell me what to write down.
Multiply a times c.
Multiply a times c, right? We're going to start with the AC method. So a times c is going to be what in this case?
The 4 and
One.
the 1.
4 times the negative 1, get negative 4. What are the factors of 4?
What
1
times?
and 4 and 2 and 2.
1, 4, 2, and 2. Good. Now, which of those factor pairs am I going to use to actually factor this polynomial?
2 and 2.
2 and 2?
Yes.
Are you sure?
It would
Remember,
be-
we're trying to get the
Oh,
middle
no.
term, right?
Oh yeah. 1 and 4.
-1 and 4, right?
Yeah. And specifically, we need -1 and 4. I just always hold that negative discussion until a little bit later, right? Because you sort of look at those factors and you say, okay, what looks like it's going to mix together to give me that 3, right? And so then you sort of figure out what signs you need there. But -1 and 4 is correct because -1 plus 4 will give us the positive 3. Okay. Now I'm going to go over here and tell me if I'm doing this correctly. Negative x plus 4x. Is that right?
No, you need your squares.
Okay, good. X squared, 4x squared. Okay. What do I do now?
You bring down the other terms, 4x to the 4th, and then -1.
Good. You guys are flying through this. Okay, what's the next step?
Factor out the problem.
Yeah, we need a factor by grouping now. We'll look at the first 2 terms. And what's their greatest common factor?
X to the 2nd.
X to the 2nd. If I factor that out, what do I have left over in parentheses?
Or -1.
Okay, that's a good first step. Not entirely there. Let's go ahead and multiply this out to see if we get what we need, right?
Four- Wait, you're missing an x to the 2nd and a 4. It needs to be 4x to the 2nd.
There we go. Right? Everybody okay with that? Because now that multiplication works out. X squared times 4x squared gives you the 4x to the 4th power. And then x squared times -1 gives you the negative x squared. Okay. Good. Now, over here in the second set of terms, the first term is positive. So we're just going to bring out a plus. But then what do these guys have in common? What's their greatest common factor?
X squared.
Well, I can sort of see why you would think that. The first term has an x squared, the second one doesn't,
Oh, right.
right? So we can't pull out an x squared if we don't have an x squared.
Would it be 1?
Yeah. So you're thinking of the largest number that divides into 4 and 1 evenly. And because 1 is already small, right? The only thing that's going to divide into 1 is 1. So you might say to yourself that they don't have a common factor. Sometimes I say that. But remember, if you're looking at 2 numbers and they don't seem to have a common factor, they always have a common factor of 1. So we'll factor out a 1. And then what goes in the parentheses?
4x squared -1.
Or x squared minus 1 again. You could just transplant that over from the other set of parentheses if you didn't want to do too much thinking, but then you go ahead and multiply that out and make sure that it makes sense. 1 times 4x squared is going to give you 4x squared. 1 times -1 is going to give you the -1, so that works out. Okay. Now, what's the next step?
You group x squared plus 1 equals 0. You do the
Yeah, I think that you're getting one
Zero
step ahead of me,
factor.
though. Yeah, you're on the right track. You're just zooming through this part. We're just going to put x squared plus 1 and then 4x squared minus 1. Those are our factors. And we can set them equal to 0 now, right? Then we can set them equal to 0 individually. So x squared plus 1 equals 0, or 4x squared minus 1 equals 0. That's using the 0 factor property. Okay. Does anybody have any questions about that? Okay, so this question or this equation on the left-hand side, how do I start solving that?
You gotta isolate the x
subtract 1.
Subtract 1, right? Isolate the x squared. So subtract 1 from both sides so that we have now x squared is equal to -1. Now, how do I solve that quadratic equation?
With the square root.
With the square root property. So we'll use the square root on both sides so that the square root and the square cancel. We'll get x is equal to plus or minus. And what is the square root of -1?
Would you just put I
Yeah.
for the answer?
Yeah, so I don't think that we've had one that looks like just the square root of -1 yet, but remember, by definition, the square root of -1 is the thing that we can't really deal with, and that's the thing we're calling our imaginary unit, I. Right? So you wouldn't be able to do this in the calculator, you just have to remember that the square root of -1 is I. Okay, so we have two solutions there. How would I go about solving this right-hand equation?
You could start by adding 1 to both sides.
Go ahead and add 1 to both sides. We have 4x squared is equal to +1. Then what? It's a little bit different, right? Looks like it has an extra step,
Yes.
but we're trying to get the x squared by itself. So how can I move the 4 to the other side of the equation?
Can you divide it?
Yeah, absolutely, because 4x squared is 4 times x squared. So we can certainly divide out that 4 to cancel it on the left-hand side. Right, so now we'll have our x squared is equal to 1/4. Okay. And then what do we need to do?
Would it be the same as the other side, the square root? It's just
Yeah.
confusing because it has a fraction.
Yeah, so don't worry about it having a fraction, right? If you're having a little speed bump in your head as soon as you see a fraction, that should tell you that like the only reason you're not going to the next step is because you're a little bit afraid of fractions. We just need to take a deep breath. Fractions, just like any other number, you solve these equations the same way. So if we're trying to get the x by itself, we'll use the square root property so that we have x by itself now because the square root and the square cancel. We need our plus or minus. And then if you have your calculator on hand, which I suggest that you get if you don't have it, go ahead and take the square root of 1/4. What should you get? What does your calculator say?
1/2.
1/2. Right? And that's not too bad. That's not too scary. So there we go. There's two solutions there. We have two solutions over here. So then our solution set consists of I, negative I, positive 1/2, and negative 1/2. Okay, I just wrote it out in expanded form so that we can see and count that we have 4 solutions. If you only have 2 solutions in your solution set, then you have not completed the problem, right? So make sure that when you're solving these quartic equations that you have 4 solutions. Does anybody have any questions or comments about those 2 problems that we just did?
No.
Any comments or feelings, commentary that you want to add to it? Does that feel okay?
Yeah, I just got thrown off because there was a fraction. That's all.
Okay, good, good. Anybody else?
They're pretty simple so far.
Okay. All right. I think in the interest of time, those are the only 2 examples that I'm going to give us on solving a quartic equation. Okay. My hope is that because it looks similar enough to solving a quadratic, that we don't need a whole lot of practice to get that one down. Okay. I will be throwing together a practice test for us to work on tomorrow in person. So we should get more practice with this, but we're going to have to move on to the next type of equation that we're going to solve. Okay. So let me go ahead and pull that up. Just one moment. This is going to be a little bit more involved. These are called rational equations. Let us see. Let's find a good example. Something that's not too strange. Okay. I think we're just gonna have to jump in. It's hard to describe, the general form for a rational equation because they all look sort of similar, but they can have a lot of different terms. Last week, we talked about rational expressions. And we distinguished them from polynomial expressions in that a rational expression could look something like 3x minus 1 over 3, right? Sorry, that would not be a good one. That would just be a polynomial, actually. Let's go with 2x over x minus 1. Okay. Now, the thing that makes this different from a polynomial expression, remember we said a polynomial is a sum or difference of terms. That is, you have a bunch of things that you're adding or subtracting, and they could have numbers or variables connected to them. But you cannot have variables in the denominator of an expression or a term. Okay. So rational expressions are these things that have variables in the denominator, and that causes some problems for us, right? Because if we have a variable in the denominator, or in the bottom of a fraction, then depending on the value of x, depending on the value of the variable, it's possible that that expression could force us to divide by 0, which last time we saw you can't do, right? If you type, something divided by 0 in the calculator, your calculator explodes, tells you that it can't do it. Okay. So we came up with this concept that there are some values. There's a value or some set of values that we cannot use for that expression that are not in the domain of that expression. Okay, but every other number works. If you look at this expression that I wrote down, 2x over x minus 1, can anybody tell me what the restricted value or values are for this expression? You guys remember how to find it?
No,
Okay, good. Especially in Zoom, you know, I can't see your faces, so it's important to be vocal here. So if you don't remember, what we do is we said if we don't want to divide by 0, then this thing in the bottom can't be 0. So for some expressions, you can just look and say, okay, x minus 1, what is going to make that equal 0 if I plug it in for x? Something minus 1 gives me 0. What is that something?
1.
1. Okay, but you don't want to just look at it and sort of eyeball it every time, because the denominator could be more complicated, right? We saw some quadratic denominators in the past. So what you should do is just set the denominator equal to 0 and then solve that equation, and that will tell you what the restrictions are. So if we needed to solve this equation, we just add 1 to both sides. X is equal to 1, and that's how we know what our restriction values are. So I know then that x cannot be equal to 1 for this expression, because if I plug in, you know, 2 times 1 over 1 minus 1, I would get 2 over 0, and that would be a problem. Right? Does that make sense?
Yes.
We do not want to divide by 0, and so that's what we have to watch out for when we're dealing with rational expressions. Okay. So what does a rational equation look like, right? Rational expressions are made up of, rational equations are made up of rational expressions. So if you're going to get some problems that say solve the equation, and let me go ahead and write this down, and then we'll talk about it. So we might have something like 4x plus 3. All of that is over 4. That's a rational expression. Doesn't seem to cause any problems because there's not a variable in the denominator actually. So, but we might have something like minus 4x over x minus 4 is equal to x. Okay. So remember, expressions don't have an equal sign, equations do. So this is our first rational equation. Okay. So let me give you guys a moment to write that down. And I'm going to walk you through sort of what you need to be thinking about as you approach these. And there's a lot to think about here. The first thing that we need to think about is we need to find the restricted values. Why do we need to do that? Well, for these equations, if we get our solution set, so let's say we do all the math that we're going to do here in a second, and we get to the end of the problem, we have our solution set, but that solution set just contains numbers that we know are restricted, that are going to force us to divide by 0. Okay, that happens sometimes where you solve the equation, but then it turns out that that solution is restricted. If that number forces you to divide by 0, then you cannot use it as a solution. So we have to throw it away. So the first step for solving these kinds of equations is to go term by term to figure out what the restricted values are for each of these rational expressions. So the first thing we need to do is look at each term. I like to number the terms. Okay. And when I say term, I just mean that big object, that chunk of information that looks like a fraction. Okay. Another way of distinguishing the terms is they're the things that are separated by the plus or minus sign. So this fraction, even though it's big and overwhelming, is a single term. 4x plus 3 is a polynomial divided by 4. Minus, we got our second term, 4x over x minus 4. Okay, that's a true rational expression because it has a variable in the denominator. And then on the other side of the equal sign, we just have an x. That's going to be our last or our third term. So you need to be able to sort of see how many terms and count how many terms are in the problem, and then look term by term and figure out what's going to be a problem here as far as our restricted values. So for this first term, look at the denominator. Will the denominator, is there a variable in the denominator?
For the first term?
Yeah, for the first term, is there a variable?
I say no.
No, it's just the number 4, right? So if it's just the number 4 and you don't have a variable in the denominator, you don't have to worry about it, because that 4 is never going to magically change into a 0. It can't. 4 is a fixed value. Okay, the only way you're going to get a 0 in the denominator somehow is if there's a variable down there. So we don't have to worry about this. Okay. The second term, 4x over x minus 4, does that have a variable in the denominator?
Yes.
It does. So because it does, that means this is a true rational expression, and we have to assess whether it has a restricted value. So to do that, I'm going to put x minus 4, set that equal to 0, and solve for that restricted value. So what should my restriction here be?
Positive 4.
Positive 4, right? If I add 4 to both sides, x equals 4, which tells me that it's a restricted value. X cannot be equal to 4. Because if it is equal to 4, then I would be dividing by 0 for that second term. Does that make sense?
Yes.
Okay. The third term on the other side of the equal sign, we just have x. Does that have a denominator?
No.
It doesn't. Now, I know you could say, you could throw it over 1, and that would be the same thing. But even if we did that, the denominator of 1 wouldn't make a difference here. It doesn't have a variable in the denominator. So we don't have to worry about that one ever forcing us to divide by 0, because it's not a fraction. Does that make sense? So the only restricted value that we have, I'm going to put RV, is 4. Okay. Does anybody have any questions?
No.
Okay. You're going to have to do this process of checking for restricted values at the beginning of each of these rational equations. We haven't even begun to solve this thing yet. We're just assessing, doing some prep work to make sure we don't run into any trouble later. Now we're going to actually begin to solve the equation. So I'm going to rewrite it. 4x plus 3 over 4 minus 4x over x minus 4 equals x. Okay, now I'm going to start solving. Okay. Now, the tricky thing with rational equations is that you have a bunch of fractions. And I know that a lot of us have trepidation, have some fear whenever we start to see fractions, especially when we have variables thrown in the mix. But in the past, we solved equations by clearing the fractions, by getting rid of fractions, by multiplying in the greatest common factor. I'm sorry, the least common denominator. There we go. My bad. So we need to find the least common denominator of all of the terms. Okay. So for a moment, let's just ignore this problem for a second and think about something simpler. Imagine that I had 1/2 x plus 4 over 7 equals 10. Okay. if I wanted to get rid of my fractions, I could multiply a number that will help me eliminate these fractions. That number is the least common denominator of all the denominators in this problem. Can anybody tell me what the least common denominator of 1/2 and 4/7 is?
Would it be 14?
Yeah, it's 14. That's the LCD. How did you get 14?
Because 2 times 7 is 14 and 7 times 2 is 14.
Yeah, exactly. So with the easiest way to find a common denominator, it might not always be the LCD, but the rule of thumb here is that you just need to multiply those denominators again, right? 2 times 7, and you get the LCD, right? Then I would tell you, go back into the problem and multiply 14 here, multiply 14 here, and multiply 14 here, right? Because in doing that, you could say 14 divided by 2 is 7 times 1x, which is left over. 14 divided by 7 is 2, but we have a 4 left over, so I'm going to multiply that by the 4 that's left over, equals, and then 14 times 10. There's nothing that cancels there, so I'm just going to leave it as 14 times 10. Do you guys remember when we did that trick to clear the denominators to get rid of fractions? You don't have to remember it fondly or like remember it well, but do you remember us doing something like that?
Yes, but I just wrote it different. I didn't write it like that.
Yeah. So if you came up with your own style of writing it, that's fine. But the only reason I bring this up and demonstrated it, I'm not going to complete this problem, is because that's exactly what we need to do over here in this rational expression. So if you look at this rational equation, we have the 3 terms. To find their least common denominator, you multiply their denominators. So what's the denominator of the first term?
4.
4. What's the denominator of the second term? Anybody?
What was the question again?
What is the denominator of the second term?
Would it be x minus 4?
Yeah, I mean, that's all I'm asking, right? What's the denominator of the second term? Right? Not a trick question. X minus 4. What's the denominator of the third term?
It doesn't have one.
It doesn't have one, so we don't have to worry about it, okay? So what I'm saying is that just like when we took a step over here and look at this simpler problem, and I said, okay, what's the common denominator between 2 and 7? And we just multiplied the 2 times 7 to get that. When we're looking at this more complex problem, 4x plus 3 over 4 minus 4x over x minus 4 equals x, it's crazy to look at. The LCD that you're looking for is just take each of the unique denominators and then multiply them together. I'm throwing air quotes here. I'm not actually going to multiply this out, but I'm just going to stick them next to each other. Okay. This is my LCD. Now what I'm going to do is take that LCD, is multiply the LCD into the equation. Okay. Just like we did with that 14 in that side example, we're going to multiply this 4 and the x minus 4 into our equation. So every single term, we have 3 terms here. Each of those terms is going to get multiplied by this LCD that we wrote down. Okay. So I'm going to write down my equation one more time. X Let me go ahead and mute this while the train passes too. Okay, the train has more or less passed. Okay, now I've rewritten the equation down and it might look a little bit strange because I've left some gaps. I am going to take my LCD and multiply it by each one of these terms. So I'm going to put 4 times x minus 4 here. 4 times x minus 4 here. 4 times x minus 4 here. Okay.
No. I don't know.
It's a lot of writing, I know, and it looks even messier than before. But just let me know when you're done writing this down and I'll move on to the next step.
Okay, I got it.
Okay, does anybody else need more time?
Oh, they're over here.
Okay. Was that you did need more time?
No, I'm good up here.
Okay, cool. Okay. So now that we've done this is my favorite part of the problem. Okay. Now, a lot of times students forget how to multiply fractions, but that's exactly what we're doing. This LCD that we have does not have a denominator. It doesn't need one. But if you want to make it sort of nice and balanced, you could put all of this over 1. All of this over 1. And then we don't really need an over 1 over here. I'm just trying to make this balanced with fractions. When you multiply fractions, typically, we multiply the stuff on top and then the stuff on bottom, right? We multiply straight across. I'm going to get rid of these over 1s here. But the other way that I said we could do this is by just interpreting the fractions denominator as division. So if we're multiplying this thing, this LCD, into the equation, eventually it will be divided by the denominator that's already there. And if we have a denominator that's a common factor with the numerator, that is, like if I extended this and say all of this stuff is in the numerator, all of this stuff is in the numerator, do I have a common factor if I look at this first term in the numerator and the denominator?
Four?
4, right? This 4 and this 4 here are your common factors. So we can cancel them out. That means what we'll have left over is x minus 4 times the stuff that was already there, which was the 4x plus the. Does that make sense? We just cancel the common factor?
Yes.
Okay. Well, remember last week at the end of, I think on Thursday, we covered simplifying rational expressions. That's exactly what we're doing here. We just cancel a common factor, write down whatever's left over, and that's what our answer is for those kinds of problems. Okay, so we're done with the first term. We've canceled what we can cancel. We're moving on to the second term. For this second term, is there a common factor in the numerator and the denominator?
Would it be the -4?
It's not the -4, but I think that you're on the right track here. If you're looking at this x minus 4 here, that whole polynomial, and this x minus 4 here, those are a common factor, right? They're the same,
Oh, okay, yeah.
right? If those are the same, then we can cancel those out. Because x minus 4 divided by itself is 1, so we say that cancels. What's left over is the -4. We cancel out the x minus 4, but we still have this 4x. Okay. Does that cancellation make sense?
Yes.
Okay. Moving on to the next term. Well, I multiplied this LCD, the 4 and the x minus 4, and I'm multiplying that by the x. Is there a denominator here?
No.
That means that there's not going to be anything that cancels, because we can only cancel numerators with denominators. And if we don't have a fraction, nothing's going to cancel. Okay, that means we're just going to have to multiply this out. For now, I'm just going to write this as 4 times x minus 4 times x. Okay, and we'll do the multiplication in the next step. But notice that in this line here, this whole thing now no longer has any fractions. There are no more denominators. So the fourth step that we need to get to is that this is really messy. There's a lot going on here. We need to multiply and combine like terms. So what we would say is simplify the equation. And usually when I say that, I mean distribute what you can distribute and then combine like terms. Okay. So if I'm looking at the first set of terms, if I were to distribute that out, I would get x times 4x is 4x squared. Are you guys okay with that?
Yes.
And then x times positive 3 would be plus x. -4 times 4 would be -16x. And then -4 times 3 would be -12. Are you guys all right?
Yes.
All we did was multiply the next. Then we're going to multiply this out. What's -4 times 4x?
-16x.
-16 equals. Well, this one is a little bit unclear to look at because we're multiplying 3 things. Right? We're multiplying 4 times x minus 4 times x. So, but so that doesn't confuse you, what I would do is write this as, again, the order of multiplication doesn't matter, but we can do this. We can get it as 4x times x minus 4. And then distribute that. Okay. So if we distribute that out, what's 4x times x?
4x squared
4x squared. And then what is 4x times -4?
-16x.
-16x. Good. Okay. Still looks really messy. All we did here was distribute some things out. Let's combine like terms if possible. So for the left-hand side of the equation, do we have any like terms that we can combine? going to bring the 4x squared down because that's the only one that we have. It looks like we have 3x, negative 16x, negative 16x. So if we combine those, you can use your calculator and do positive 3 minus 16 minus
Negative 29.
negative 29.
X.
Right. And that should make sense because negative 16 and negative 16 is negative 32. And then when you add 3, we should get to 29. Yeah. So negative 29. And then we'll just bring the minus 12 down. Well, right away, this is looking sort of like a quadratic equation, right, as we start to simplify. On the right hand side of the equation, we just have 4x squared minus 16. So we're just bringing that down. There's nothing to combine over there. Minus 16x. Okay. And if you make a mistake like the one I was just about to make, you're going to be pulling your hair out because we've already done a lot to think through this problem. Okay, so be very careful that you don't lose a variable or lose a sign. Okay. Now, this thing is starting to look like a quadratic equation, but we need to get this in standard form or set equal to 0 in order to solve it. So what I'm going to do is subtract 4x over here, or start 4x squared, so that I can move it over here, minus 4x squared. Okay, I'm also going to add 16x here and add it over here so that these guys will cancel out and give me my 0. Does that make sense?
Yes.
Okay. What is 4x squared minus 4x squared?
It cancels out.
Cancels out, right? That equals 0. Negative 29 plus 16.
Negative 13x.
Negative 13x. And then we just bring our minus 12 down, right? Well, this thing that we have left over, negative 13x minus 12 equals 0. Can anybody tell me what kind of equation is this? All we've learned how to solve so far, until we got to this section, obviously, were linear or quadratic. This negative 13x minus 12 equals 0. Is that a linear equation or is it a quadratic equation?
A linear equation.
It's a linear equation. So we just need to solve this the way we'd solve any linear equation, and that is isolate the variable. So at this point in the problem, when we distributed some things out, combine like terms, you will end up with either a linear equation or a quadratic equation. And then you just solve that. So that would be our 5th step, to solve whichever equation we have left over. It's either going to be linear or quadratic. Okay. So if I want to isolate the variable x, how would I start to do that?
You add 12 to each side.
Let's add 12 to both sides. Negative 13x is equal to 12. And now how do I get the x by itself?
You divide by negative 13.
Perfect. Negative 13 divided by itself is just going to be the 1x. Okay. And then it's going to be negative 12 over 13. Now you could throw that in your calculator. Remember, your calculator will reduce that fraction for you. But that being said, this fraction is not reducible. It is fully simplified. So this, we would say, is our potential solution. Provided that we've done everything correctly up to this point, we haven't lost any sign, we didn't miswrite something, your equations should get simpler as you work through them, right? And then you should get your solution here. But the thing that you want to watch out for is we've done a lot of work here. Okay, the first thing that we did was ask ourselves, what is the restricted value, or what is the set of restricted values for this equation? and we said that our restricted value is 4. So if our restricted value is 4, we can say that this cannot be a solution. Okay, based on all the work that we did, we got the solution negative 12 over 13. Is that a restricted value?
No.
That means that this solution is okay. This is not restricted. Let me go ahead, not restricted. So we should be good. Okay. Again, there are certain situations that we'll get into where you solve the equation and then that's a restricted value. Okay. So if that's the case, then we're gonna have to throw those solutions away. Okay. Does anybody have any questions?
No.
Not right now.
Not right now. We're gonna do another one of these. I'm gonna go a little bit faster here. And then we'll go ahead and take a break after this next one, okay? So let's solve. Let me zoom in a little bit. Three over x minus 3 plus 7 over x plus 8 equals 5 over x squared plus 5x minus 24. Okay. Again, I apologize for the handwriting today. Writing on my computer screen is a little bit tricky. Okay, let me know when you've written that down and we can jump in.
I'm done.
Okay. When you're looking at a rational equation that looks like this, for the first two terms, and I like to number the terms so that we get used to identifying how many terms are in the equation. Just has 3 terms. The first 2 terms, they have simple denominators, x minus 3, x plus 8. So if I were to look at this first term and ask you, what's the restricted value here? What value of x is going to force us to divide by 0? What would that number be?
3.
3, right? Because 3 minus 3 would give you 0.
So you kind of broke up a little bit. What did you say?
I just asked, what is the restricted value for this first expression, the first term? Right, what's going to force you to divide by 0? And Diana said it'll be 3, because 3 minus 3 in the denominator would force you to divide by 0, right?
Right.
For the second term, what is its restricted value?
-8.
-8, right? So what I'm trying to train you to do is, like, for these simple denominators, you can sort of eyeball them and find that those are restricted values. So right off the bat, restricted value should be 3 and -8, that those are restrictions. Okay, because they're both of those numbers, if we plug them in for x, are going to give us problems. But for this last term, can anybody identify what the restricted values are by just staring at that denominator?
-5. One of them would be -5.
Why would it be -5?
Just say 1 to to cancel out the positive 5x.
Oh, I see. I see what you're saying. But that actually, like, this is harder to deal with when it's in this longer polynomial, right? It looks like we have a quadratic trinomial here. If you were to factor this thing using the AC method, you would see that you get the following factors. Okay. Now, I'm not going through the AC method process here. I'm just trying to get you to say, if you were to sit down with a scratch piece of paper and factor this using the AC method, at the end of that process, you would get x minus 3 and x plus 8. And just to prove that that's true, if we went ahead and multiplied that out, you would get x squared, you would get positive 8x, you would get minus 3x, and then you would get negative 24, right? You combine like terms, x squared plus 5x minus 24. That's the exact same thing that we started with. Okay, so here is the pro tip. I'm going to erase this scratch work here. Delete that. That if you have a complicated trinomial in the denominator, it's best to rewrite that problem in factored form. So for first two terms, there's no work we need to do. We're just rewriting them the way they were originally written. But for this term, we'll write 5 over x minus 3 times x plus 8. We'll go ahead and write that in factored form. Because if the denominators are in factored form, you can see that the two restricted values that we have already, those are restricted for this last term as well. Okay, so there aren't any different restrictions from what we already obtained. Okay, and this is the pro tip, that when you work these problems out in the homework, if you have a quadratic trinomial in the denominator of one of those terms, then usually it's going to be factorable into the other denominators that appear in the problem. Okay. Okay. Well, that being said, step one is finding the restricted values. We write that complicated denominator in factored form just to see that it's going to have the same restrictions that we found for the first two terms. Okay. The next step is to find the LCD of each of the terms, the least common denominator. But to do that, we just need to put the denominators together. So we have an x minus 3 over here. We have an x plus 8 over here. And then we already have x minus 3 and x plus 8. So we don't have to copy those another time, right? We just need to write down and multiply together. I'm using air quotes here, multiply x minus 3 and x plus 8, and that's going to be your LCD. I'm going to put a little wall here. This is my scratch work. Does anybody have any questions or comments before I move on?
No.
The question could be, what did you just do? Or the comment could be, I have no idea what you're doing. That's perfectly fine. Just give me an opportunity to clarify if you guys get lost. What I'm doing is just trying to go through the same steps that we did for the last problem. We identify the restricted values. Sometimes that's actually more complicated than what the last problem was easier to do. And then the second step is to find the LCD, which again, I'm just trying to get you to identify that the LCD is made up of the denominators that you have there, just multiplied together. Okay. Now, once we have the LCD, what was the third step? Does anybody remember? Take a look at your last problem.
Multiply LCD into the equation.
Yeah, we're going to multiply the LCD into the equation. So we need to multiply that by each of the terms that we have. I'm going to go ahead and write the equation again, but this time I'm going to write it a little bit smaller and give myself a little bit of space. So I put a little gap here, a little gap here. 7 over x plus 8 equals, I'm going to put a little gap here, 5 over x minus 3 times x. I'm going to continue using that in factored form. Okay, and then I put my LCD and multiply it into the equation. Okay, so sorry, I'm having to squeeze this in. X minus 3 and x plus 8. X minus 3 and x plus 8. X minus 3 and x plus 8. Okay. I'm going to give you a chance to write that down. I know there's a lot of writing. Just let me know when you're ready to proceed.
Already.
Okay. Anybody need more time? Or anybody need to clarify what I've written, because I realize that on the computer screen it's rather messy.
Also messy on my end, sir.
Okay. It
Okay.
happens.
Yeah, me too.
Okay. So what we do for the next step when we're multiplying that LCD into the equation is we're going to cancel out the parts of the LCD that are in the denominator of each of our terms. So this term, we're going to go term by term, has now an x minus 3 in the numerator and an x minus 3 in the denominator. So we can cancel those out. Okay. What is left over is, and don't mind me, but I'm going to rearrange it. This is the 3 that we had here and the x plus 8. Okay, so we cancel what we can cancel. Whatever's left over, you're going to end up multiplying out in the next step. Okay, so we're just going to write that down. We move on to the next term. We have x minus 3 and x plus 8 that we just multiplied in. And the denominator has what? It has x plus 8. So that is a factor that we have in common here. We're going to cancel those out. So again, don't mind me. I'm just going to rearrange this. As I write this down, I'm going to put the plus, and then we just have a 7, and then the x minus 3 left. Is everybody okay with that? Is anybody not okay with that?
I'm okay with that.
Okay. Moving on to the last term. The last term is really nice, actually, because we've multiplied in our LCD, the x minus 3 and the x plus 8. But both of those, the x plus 3 and the x minus 3 and the x plus 8, those are both in the denominator. So this x minus 3 cancels out this x minus 3. This x plus 8 cancels out this x plus 8. So what we're left with is just 5. Does anybody have any questions about the cancellation there?
Not over here.
Okay. So again, we're multiplying the LCD in so that we can cancel common factors for each term. And what that does is it makes the problem look a lot simpler, right? No more fractions. So now all we have to do is simplify the expression or simplify the equation by distributing and combining like terms. So these two multiply out or distribute to give us 1. Everybody okay with me writing 3x plus 4? Okay. Moving on to the next set of terms. I have 7 that I need to distribute into the x minus 3. That's going to be 7x minus 21. Is everybody okay with that?
Yes.
There's nothing to do on the other side of the equal sign, so I'm just going to bring the 5 down. Okay. We've distributed. Now we need to combine like terms. So we could combine like terms here and here. That would be 10x, right? And then 24 minus 21 is 3, positive 3 equals 5.
Yes.
Okay. So now that we've simplified the equation, what type of equation is this?
A
You got it?
linear
Yeah.
equation?
It's a
Okay.
linear equation, right? Linear just has x, quadratic has x squared. We don't have an x squared, so this is a linear equation, and we just need to solve this linear equation now. Okay. So how do I solve this linear equation?
Subtract 3 from each side.
Subtract 3 from both sides. We'll have 2 over here now, and we have 10x. Okay. How do I get the x by itself?
Divide by 10.
5 by 10 on both sides. Simplify your fraction. We should get 1/5. Okay. Always, always, always with these, when we get our solution, you have to check it. Does anybody remember what our restricted values are?
3 and negative 8.
There were 3 and 8.
They were 3 and negative 8. Is this 1 over 5? Is that 3? Is it negative 8? It's a weird question to ask, right? Is this number this other number? Not the same numbers, right?
No.
That means that this solution, good. No problems there, because it was not one of our restricted values. So that is a perfectly fine solution. Okay. Let's take a break and come back at roughly 10:30. Let's say 10:31, 10:32. Okay. Well, let's take a 10-minute break just so that we can clear our heads a little bit. Okay. Walk around, go get some water, do what you got to do.
Great, thank you.
Okay. So just to recap, I couldn't possibly cover every version of these types of questions or these types of equations. You're gonna have to get into the homework and just practice that. If you run into any problems, just send me a message and remind. And I'll try to give you some notes on where things are going wrong or where things are going right, okay? Now that we've solved quartic equations and rational equations, we have the last 2 types of equations that we're going to solve are intimately related to each other. So I'm going to start off with radical equations because I think the logic here is going to make some sense. This is related to section R7 when we were simplifying radicals. So let's go ahead and just write that down. Radical. Okay. Now, a radical expression looks something like this, say ax plus b, right? Just some stuff trapped underneath the square root. Usually we have equations that are just square roots, but sometimes that's going to be an nth root, so it could be a cube root. This is a radical expression. Okay. So for these kinds of equations that we're going to work on here, we're mostly going to be seeing square root equations and cube root equations. But the logic transfers over to the nth root. It could be a 4th root, it could be 5th root, so on. But let's go ahead and just start with some examples of square root equations and how we can go about solving those. It's going to be one of these situations where we just learn by doing. Okay, so let's solve and then see if we can come up with, as we're solving, just a list of steps that we could take possibly. Okay, so I'm going to write this expression: the square root of x plus 3, okay, is equal to x minus 3. And the square root of x plus 3 is equal to x minus 3. Are you guys ready to dive in?
Yes.
Okay. Now, the name of the game for solving all these equations is still the same. We're thinking about getting the x by itself, but there's more operations in the mix now. When we were dealing with linear equations, the only operations that we had to worry about were addition, subtraction, multiplication, and division. Now we have to worry about, with quadratics, we have to worry about exponents, like something raised to the second power. How do I, cancel out the second power? Well, we then learned about roots and radicals, and we figured out that we could cancel out a second power with a second root, right? The square and the square root are opposites. So it is not a mistake that I've rewritten the equation here. I'm going to ask you a question. Look on the left-hand side of this equation, right? That's the statement first. This thing is a radical expression, right? Let me go ahead and maybe I'll say that this is a radical expression. Okay, that's our radical. You want to, before you start moving things around or trying to cancel things out, you want to make sure that your radical expression are isolated. That is, the entire radical expression, the square root of x plus 3, is on one side of the equal sign and it's by itself. Okay. All the other terms, the x minus 3, are on the other side of the equal sign, and that's how you want to begin. So if for whatever reason, let's change the problem just momentarily. Let's say I had that radical expression, and then I had plus 3 is equal to x. Okay. If that radical expression, the stuff underneath the radical symbol, had that plus 3 on the outside of it, and it was on the same side of the equal sign, well, I could subtract 3 over to the other side of the equation so that I get the radical isolated. You always want to start with that radical being isolated. Okay. Does that make sense? Okay. Well, now the reason why you want the radical isolated, I'm going to move this down so I have a little bit of space to work, is because you're going to ask yourself, well, what root is this? And what is going to cancel out that particular root? So what's the root that we're looking at in this problem? Square root. Right. So if we have the square root, what is the opposite of the square root? What operation will cancel it out? Maybe I need a refresher, right? Maybe I need to refresh our memory here. Remember that when we're talking about roots, that their opposites, I put verses, are exponents, right? So if I have the second root, I'm going to put the square root here. If I have the third root, that's something different, right? What is the opposite exponent that's going to cancel it out?
A 2.
A 2, right? Raising something to the second power, right, is going to cancel out that square root, right? In the same way that we said, if we have x squared, the take the square root and then those cancel out to give us x, right? Does that make sense? So if those are opposite of each other, then I can use that information, right? And the same thing with the cube root and then raising something to the third power. Those are going to be opposites of each other and they're going to cancel out. So what I'll do in this equation is I'll take the left-hand side of the equation and the right-hand side of the equation, and I'll square them. Because I know that on the left-hand side, the square root symbol and the square will cancel out, leaving me with just x plus 3, the stuff inside the square root. That's free now, right? We've sort of taken it out of prison, so to speak. Does that make sense? That we can cancel that out on the left-hand side?
Yes.
Okay. Now on the right-hand side, we didn't have a square root to cancel out. So now we've created sort of a new problem for ourselves. We solved one problem, created another one. X minus 3, that entire polynomial is now being squared. Can we simplify that expression? Well, sure we can. If we remember our definition for exponents, we could say that this is the same thing as x minus 3 times x minus 3, right?
Yes.
So if I multiply that out, I should get x squared. And actually, let me give myself a little bit of grace, a little bit of room. I'm going to move this up just a tad. I'm going to multiply that out. I'm going to have x squared minus 3x minus another 3x plus 9. So what I get when I combine my terms there is x squared minus 6x. Be careful not to cancel those out because they don't have opposite signs. Plus 9. Okay. Is everybody okay with that?
Yes.
Okay. So really, that radical equation that we had, we needed to cancel out the radical by using the opposite power, and that's what we've done here. Now we're dealing with an equation that looks sort of kind of like a quadratic equation. Okay? If we were to move all of these terms over to one side and get this set equal to 0, then that would look like a quadratic equation. So what are we on, step 3? Step 3 is going to be simplify. And I'm going to put here, we're going to get this in standard form, set equal to 0. Right, if this was a linear equation, you know, if I didn't have this x squared term, then I'm just solving for x. But because I have that x squared term, I know that I need to solve this like I would a quadratic equation, and that's why I need to get it into standard form. Okay, so what I'm going to do is I'm going to move this x over to the other side. So I'm going to subtract x. I'm going to subtract 3, subtract 3. Okay, now I'll have 0 is equal to, because these cancel out, 0 is equal to x squared minus 7x, and then that should be plus 6. Does anybody have any questions there?
No.
Okay, well now, for sure, this is just a quadratic equation. So there's 2 methods that we could probably use to solve this thing. The square root property won't help us because we have this middle term. What method do you think we should use to solve this quadratic equation? How do we usually solve quadratics?
Would it be the AC method?
The quadratic formula?
Yeah, those are 2 perfectly those are the 2 responses I was looking for, right? If this thing is factorable, then we could factor it using the AC method. Regardless of whether it's factorable, the quadratic formula will work, right? I like factoring, so I'm going to go ahead and jump into the AC method here. So A times C is going to be 1 times 6. Are you guys okay with that?
Right.
So that's just going to be equal to 6. I'm looking at the factors of 6, which are 1 and 6, 2 and 3. Which of those factors are going to add or combine in some way to give me the -7?
One and 6.
The 1 and the 6. Okay. Now,
Yeah.
this is a positive 6, right? That tells me that to multiply these numbers together, they either both have to be positive to give me the positive 6, or they could both be negative to give me the positive 6, right? So which one of those am I going to choose? Both positive or both negative?
Both negative.
Both negative, because I need to be able to add them together to get the middle term. So I'm going to call this minus x minus 6x, and that is -7x, right? So because those combine to make that middle term, we're on the right track, okay? And again, they take on the variable of that middle term. So when we're solving quartic equations, that middle term was an x squared. We don't have to worry about that x squared now because the middle term is just an x. What we will do is bring down our terms x squared and our 6 here, and then we can factor by grouping. These two terms have what in common?
An X.
They just have an x in common. So I'll factor out an x, that leaves me with x minus 1. And then these two terms have what in common? I'm going to put a minus sign because the first term is negative.
They both have 6.
They both have a 6 in common, right? 6 is the GCF for both of those. And then if I don't want to think too deeply about this, I'm just going to put x minus 1 there, and then just make sure that multiplication works out. -6 and x gives me the -6x. -6 times -1 does give me the positive 6 back. Everybody okay with that?
Yep.
Yes.
Okay, well then it's just here because we have x minus 1 and x minus 6, that is fact. And then we can say that we're going to set those equal to 0 since we're solving this equation. So x minus 1 equals 0, or x minus 6 equals 0. That's going to provide us with our solutions. So how do I solve this equation over here on the left-hand side?
You add 1 to each side.
Add 1 to both sides. X is equal to 1. That's one of my solutions. Okay. On the second equation that we have to solve over here, how do I solve it?
Add 6 to each side.
Add 6 to both. Good. X equals 6. Those are my two solutions. But wait, these are potential solutions. Okay, now the reason why I'm calling them potential solutions is because we do need to make sure you check. Make sure to check the solutions for radical equations. Because they may be false solutions. Okay, what do I mean by that? Just because we have two solutions doesn't mean that both of them are going to be valid. Okay, I've been saying, you know, when we solve quadratic equations, you can get at most two solutions. And you probably haven't been thinking too deeply about me saying at most, but sometimes you get fewer solutions. Okay, this radical equation turned into a quadratic. We got our two solutions, but now we need to check them. Okay, so how do we check? We take our solutions one at a time. So I'm going to take x equals 1 and plug it back into the original equation. Okay, so let me write the original equation down. I'm going to check. The original equation was the square root of x plus 3 is equal to x minus 3. You guys okay with that?
Yes.
Okay, this is a necessary step. I'm going to plug this in for x. Right, our solution, one of our solutions is 1. So let's check it. Square root of 1 plus 3 is equal to 1 minus 3. Okay. What is 1 plus 3 if I want to simplify this?
4.
Okay, so on the left-hand side of this little equation, I have the square root of 4 is equal to, what's 1 minus 3?
-2.
-2. Okay, let's simplify the square root of 4. What is that when we put it in the calculator? Or do you know what the square root of 4 is?
-2.
Is it -2?
Oh, hold on. Sorry. 2.
It's just 2, right? The square root of 4 is 2. And now I have a statement that says 2 is equal to -2. Is that a true statement?
No.
This is not true. And since this potential solution led to a false statement, that means it cannot be a solution. Does that make sense?
Yes.
Okay. We have to check the other one. So I'm going to set it up the same way. Square root of x plus 3 equal to x minus 3. We'll plug in 6 this time. Square root of 6 plus 3 is equal to 6 minus 3. Okay, what is 6 plus 3?
9.
So this is the square root of 9 is equal to 6 minus 3 is equal to 3, right?
Yes.
Okay, what's the square root of 9?
3.
And we get the statement 3 is equal to 3. Is that a true statement?
Yes.
This is true, which means that this is the only solution. We only had one valid solution out of a set of 2 potential solutions. Okay, so when you go in to type in your answer in MyLab Math, if you're not checking your answers for these radical equations, then and you type both of them 1 and 6 in, it's going to tell you that you're wrong, even though all the math you did was correct, right? Because you neglected to check both of the solutions. You have to check them both. Okay. If one of them is not a valid solution, you have to throw it away, and then you'll only type in the answer 6 for your solution set. Does that make sense?
Yes.
Does anybody have any questions about that problem?
No.
We're going to do one more example of this type. Okay. Let's see. That's probably a good example. Yeah. Okay. Just so that we get some practice looking at different roots, let's solve the following equation. The cube root of 4 plus 6x minus the cube root of 1 minus 8x equals 0. Okay. You guys ready to go?
Yeah.
Okay. The first step I said in the last problem was that we want to isolate your radicals. But currently, we have 2 radical expressions here. The cube root of some jazz minus the cube root of some other jazz. Both of those radicals are on the same side of the equation. And we really want them each isolated to their own side of the equation. Okay, so if I wanted to move this guy over to the other side of the equation, this may look funny, but we can use the addition principle to just move this big chunk of information over to the other side of the equation, right? Because if this is a minus sign, in between the 2 radicals, then we can cancel out the radical by simply adding it to both sides of the equation. So it doesn't matter what's inside the radical. I want you to think about this as a big chunk of information. This big chunk, we have minus that big chunk, and we're just going to add that big chunk to both sides of the equation. Okay. Because anything plus its opposite, so this negative cube root of all this stuff inside, plus the positive version of this cube root with all this stuff inside, those cancel out to 0. Okay. So what we should have when we do this is the cube root. Switch back to black ink. The cube root, we didn't touch this one, 4 plus 6x is equal to, well, these guys canceled out, and then 0 plus anything is whatever that thing is. So the cube root of 1 minus 8x. Okay, just moved it over to the other side of the equation by canceling it out. Does anybody have any questions about that part? Okay. Again, I just wanted to clarify that it doesn't matter how big or complicated that chunk of information looks like. Okay. If you have minus that thing, you can add that thing to both sides and it'll cancel out on one side of the equation. Is everybody okay with that?
Yes.
Okay.
Yeah.
Now, the reason why we want these isolated to either side of the equation is because the next step is to cancel the radical using its corresponding or its opposite exponent. So what exponent do I need to use here to cancel out the radical?
3.
3. So what I'm going to do is just like on the last problem where I said, okay, let's do something to each side of the equation. Let's raise both sides of the equation to the third power. Okay, because I know that the third root and the third power cancel out. So this is going to leave me with 4 plus 6x is equal to third root and the third power cancel out. This is going to leave me with 1 minus 8x. No more radicals. Does anybody have any questions there?
No.
Okay. You got to remember that that power and that radical cancel each other out. Okay, that's how you can figure out what's the next step. Okay. Now we have this equation. What kind of equation are we looking at here? It's either linear or it's quadratic.
Linear,
Yeah, and how do you know that it's linear?
because it doesn't have the square root.
That's exactly right. Doesn't have a square, doesn't have a second power. Okay, that's how I know it's linear. So when we're solving linear equations, it's back to test 1. We're just isolating the x. We can use addition, subtraction, multiplication, division, whatever we need to get the x by itself. Okay. So what move do you guys want to make here?
Let's see.
Adding,
Add the 1, or
I wouldn't want to add the 1.
you can
You could
subtract it.
subtract the 4.
You could subtract the 1, right? If you wanted to do that. I like to move my variables to the left first and then move my numbers to the right, or vice versa. So what I'm going to do is I'm going to subtract the 4 from both sides. Okay. You guys all right with that?
Yeah.
So I'll have 6x is equal to 1 minus 4 is -3 minus 8x. Okay. Then I like to get my variables over to the other side. So I'm going to move this by adding 8x to both sides. Are you guys okay with that?
Yes.
Those cancel. 6 and 8 is like 7 and 7, right? That's 14.
Yes.
-3. Okay. Now how do I solve for x?
Divide by 14. 26.
So now I have the solution x is equal to -3 over 14. Okay. Are we done? Not sure?
I'm not sure.
Well, this is going to be our potential solution. Okay. So for every radical equation that we have, we need to check ourselves. Okay, so even though we have one solution, that could be a false solution. I don't know. So we'll go back to our original equation. Our original equation said something like the cube root of 4 plus 6x minus the cube root of 1 minus 8x. Right, and what we need to do is plug this solution in for x. The original equation set equal to 0. Okay, so if I can plug my solution in and I get a true statement, then that's going to be a valid solution. Let's go ahead and do that check. Okay. Now, I will say, you know, if we were in the classroom right now, I could show you how to do this in the calculator. It's not the simplest thing in the world, but you could check this in the calculator. Okay, 1 minus 8 times negative 3 over 14. And essentially what we do is we have a statement here that says, if I take this radical and I plug in that negative 3 over 14 for the variable, then I subtract it from this other radical that has that negative 3 over 14 plugged in, that if you type this thing in exactly the way you've written it into the calculator, and if you get 0, then that's going to check out. Okay. But because I don't have a calculator on hand, I can't like show you on the document camera right now. I'm going to have to do this math by hand. So let's see if I can do it. Don't worry about doing it by hand because I expect you guys to do this checking in the calculator because it'll be faster. What are we going to get here? Cancel this out. 3 there, we're going to put 7 there. 4 plus negative 9 over 7. Again, don't mind me or the razzle dazzle here. I'm just checking it by hand. Factor out a 2 will leave me with a 4 there and 7 there. That'll be a plus, is negative negative 12 over 7. Okay, don't know if that's going to be equal to 0. I'm going to get this over 1, that over 1. Make this times 7 on the bottom. 7. So I'm going to have 28 minus 9 is going to be 7 plus 12 over 7. Don't know if that's going to be equal to 0. 28 minus 9 is what? 19 over 7? The cube root of 19 over 7 minus the cube root of 7 plus 12 is 19 over 7. Okay. Well, again, if you plug that into the calculator exactly the way you wrote it down, you will get to this part that I had to do manually, unfortunately. But what I'm getting here is that this cube root of 19 over 7, subtracting itself, is definitely going to be equal to 0. Okay, that means that our solution worked out because those are going to cancel out to 0. So our solution here must be correct. Okay, does that make sense? Maybe not the razzle dazzle that I did down here with doing it by hand, but again, you have a tool, use that tool to speed up the checking process. But you always need to check your solutions at the end. Does anybody have any questions? Maybe there's a lot of questions. It's just hard to ask them through Zoom, right? Okay. With the remaining time, I have to squeeze in the last type of equation. Okay. And again, we're going to have some more time to practice tomorrow on the practice test and ask questions. So do not discourage if this is going fast. It's 4 equations in one, solving 4 new types of equations in one class setting, okay? So don't freak out too badly. The last type of equation is called an equation with rational exponents. And there's a lot of ways to solve these, but the way that I'm going to show you to solve them is going to be to convert these rational exponents to radical expressions, okay? So if you remember from last week, we had this thing that was like if I had a raised to n over m, right, a fractional power, that the property allows me to convert this to the mth root of a to the nth power. Do you guys remember that?
Yeah, sorta ish.
Okay. That was in section R7, R6 in that homework. Okay. But the reason why I was like really emphasizing that you had to do that homework over the weekend was because we need to use this property here. Okay. So we're going to jump in and solve an equation that's like x to the 2 over 5 is equal to 9. Okay. Let me go ahead and make the exponent a little bit nicer. 2/5. Okay. Okay, so tell me when you guys have written that down and we'll jump in and start solving.
There you go.
Okay. Now I will say there is a more direct way to solve this thing, but the way I'm going to show you is going to be that we're going to convert this to a radical expression and then just solve this the way we would solve a radical equation, okay? And that requires you to think about what is the power, what is the root, okay? So for the left-hand side, I have this rational exponent, this fractional exponent, right? If I wanted to make use of this property that I wrote up there, I know that the second is the power, that the fifth, the denominator is going to be the root. Okay. That tells me that I can rewrite this as the fifth root of x to the second power. Let me go ahead and, there we go. Does that make sense? I can write that as the fifth root of x to the second power.
Yes.
Okay. Just making use of that property. Okay. We don't have to do anything to the right-hand side right now. We're just rewriting that fractional exponent as a radical. Okay. So that's going to be our first step. Write the rational exponent as a radical. The second step. Look at the radical. Look at the root. How are we going to cancel out the root? What power do we need to cancel out the root? I'm going to go ahead and rewrite this really quick. What power do we need to cancel out the root?
Would it be 5?
Yeah, right. Roots and powers cancel each other out. So if you have a fifth root, then the fifth power is going to cancel it out. So what I'm going to do is take this expression, raise it to the fifth power. Got to do that with the 9 as well. Okay. Now this might get ugly because 9 to the fifth power might be a really large number. That's okay. What we're trying to do here is cancel out the fifth root and the fifth power over here, so that now we just have x squared by itself. Okay. Does anybody know what 9 to the fifth power is?
59,049.
You said 59040?
49.
49, my bad. 59049?
9 to the 5th, yes. That's what I put in the calculator.
9 raised to the 5th, 59049. That's what I'm getting to. Okay. The number might be big. That's fine. Exponents make numbers grow really big. That's why we say it's exponential growth. So don't freak out just because that ballooned into a really large number. But look at the equation that we have left over. What type of equation is that?
It is
Quadratic
Um,
equation.
It's a quadratic equation, right? So now we need to cancel out the power. And how can we cancel out the power? How can we solve this quadratic equation?
the square root.
Take-
Canceling out with the square root.
Yeah, that's exactly right. So we're going to take the square root of both sides so that the square root and the square cancel out. That's going to leave us with just the x, right? We can't forget we need a plus or minus whenever we use the square root property like that. Okay. And what's the square root of 59049? Anybody?
243.
243. Yeah. Those are our two solutions. But because this was a rational expression, I'm sorry, an expression that had a rational exponent. There we go. We do need to check this. Okay. So that means that we have to go back and check the original equation and plug this in as, what was it? It was originally x to the 2/5 power is equal to something, 9.
Equal to 9.
Okay. So now what we can do is just plug this into the calculator, right? We're just going to put 243, raise it to the 2/5 power, and ask ourselves, does that equal 9? And again, you can just type that directly into the calculator. Do you get 9? Go ahead and do that for me because I don't have a fancy calculator on me right now. Fifth root of that. I think you do get 9. Yeah, you do get 9. Okay. And then you also have to check it for the negative 243 to the 2/5 power. Ask yourself, does that equal 9?
I got 9.
If you plug that into the calculator, you should also get 9. Okay, so both of those solutions work. Okay. All right. Anybody writing this down?
Yes.
Okay.
Yep.
Well, with only 5 minutes left, I don't want to squeeze in another example, but I think that this logic should check out. I will say, though, that we're not going to solve this one in the time that we have remaining, but I just want to give you a heads up because you will see some things that look like x plus 4 to the 1/4 power plus 3 is equal to 0. Okay. So we still have a rational exponent. We want to make sure that those are isolated first. So isolate. Well, I'll say convert. Let's go ahead and write it this way. Convert to a radical expression. Okay. So something like this that has that fractional exponent, we could write that as the 4th root of x plus 4 plus 3 equals 0. And then you're just solving a radical equation, right? So now we need to isolate the radical by subtracting 3 over to the other side. I know it feels like I'm solving this thing, but I guarantee you that I'm not. Okay, then we can go from there and solve the radical equation. But I just wanted to make sure that you had these key steps, that if you run into a situation that looks like this, where you have a polynomial x plus 4 raised to a rational exponent, that you're always going to convert it into a radical exponent, or into a radical expression, and then just solve that radical equation, since we've already done a few examples of that. Okay. Another thing that you're going to have to note is that the techniques that I'm giving you here to solve these equations are different from the ones that you will see if you go into MyLab Math and you click on View an Example. Okay. They might have a simpler, more direct way of showing you, but I've shown you this method so that we only had to learn basically one method to solve two different types of equations. So radical equations and rational exponent equations are really the same thing. So let's just solve them all as radical equations, okay? So if you get stuck, I'll post these lecture notes. I'm going to post this video to Canvas. Go and review that, because I think that focusing on all the different ways that you could solve these equations will confuse you more than if you just focus on what are the ways that Mr. Aguilar taught us how to solve this, okay? So if you find yourself in math world later on today, then just make sure that you pull out your notes and you show the tutors there, whether that's virtually or in person. Show the tutors your notes and say, this is how Mr. Aguilar wanted us to solve these. Because I don't want them to give you more information that's going to confuse you, right? We can talk about those other ways tomorrow, but for now, I want you to practice the methods that we covered today, okay? Does anybody have any questions for me?
Not
No,
right
sir.
now.
Okay, definitely get into the homework. Homework 1.6 should be in module 3. So make sure you get in that homework, get some practice so that it's not complete, alien hieroglyphics when we talk about it tomorrow, okay? Tomorrow we will be in person. So prepare for that unless I send out an emergency remind announcement, okay? And as always, reach out to me, send me a message that says help if you need it. Remember to like and subscribe, and I'll see you guys tomorrow.
Thank you.
Thank you, sir.
Take it easy.
I have a quick question for you, sir.
Give me just 1 second.